Assalamualaikum warahmatullahi wabarakatuh. I'm Amara.
And I'm Valinas.
We are from SMP Hidayah Surakarta. Today we will present our research in the exploration of potential use on nature and concept of static and dynamic fluids as an alternative of sustainable fishing boat propulsion. What does static and dynamic fluids exactly mean?
Basically, fluids are substances that can flow. It includes gas and liquids. Based on the movement, the fluid can be separated into two, namely static fluid for fluid that is not moving and dynamic fluid for fluid that is moving.
One of fluid nature is if the fluid is compressed, the pressure will increase. The tool that can be used to compress the fluid is a compressor.
Why the use of fluids is interesting to be explored?
The threat of climate change increases, but on the other side, fishermen rely heavily on diesel engine boats. Fluids, or in this case, is pressure-moving air, is one potential thing to be explored.
How the research will be conducted?
The research question is, can the pressure-moving air used to propel fishing boat?
This research will be conducted in two methods, by the experiment and by the simulation. The experiment is used to measure pressure, generate force, and compressor capacity, and the simulation is used to calculate the resisting force and the resulting acceleration. For each variable, a model with a certain size is used to represent the target.
Methods used for analyzing steps are: first, comparing between the thrust force and the resistance; second, comparing among sigma force, time used, and acceleration produced by one compressor tube; third, comparing among volume of the tube, volume of compressed air, and volumetric flow rate per time unit; fourth, comparing between pressurized volumetric outflow rate and inflow capacity based on the compressor specification.
Experiments to measure compressor pressure are carried out in increments of 5 seconds until the air in the tube runs out or the pressure shows the number 0. This experiment is repeated in 3 times and the results are averaged to be accurate. The average result will then be used in the calculation step.
Using the formulas, we can calculate the acceleration produced based on the sigma force, time, and pressure.
And the compressor's capacity can be calculated based on its standardized specification.
The results are as follows.
From the comparison between the resulting pressure and time, it can be seen that gradually the pressure decreases rapidly and finally runs out at the 45th second.
Meanwhile, from graph 2, it can be seen that the decrease in pressure causes the thrust produced by the compressor also decreases. When the thrust is less than the resistance, it's assumed that the object can no longer go forward, and in the simulation this occurred after the 23rd second.
Decreasing pressure causes a reduction in thrust, which finally affects acceleration. The acceleration also gradually decreases by time, the less positive acceleration obtained at the 23rd second.
As a conclusion, the use of static fluid and dynamic flow produced by the compressor is possible to apply, but it still has not achieved the efficiency.
For this reason, there are several recommendations that can be given for the further research.
To obtain efficiency and pressure stability, there are 4 things that need to be considered, which are cross-sectional hull area, tube's pressure system, tube's inflow capacity, and number of spare tubes. This is our research. Hopefully it's useful. Wassalamualaikum warahmatullahi wabarakatuh.